Optimization problem regarding Norman window. What is optimization? So optimization, let's say you run a business. So what you are trying to do is you want to spend the minimum amount of money. In the meantime, you want to maximize the amount of profit. So if you are taking an exam, this is what most people want. All right. So when I take an exam, I want to spend the minimum amount of effort to study. Meanwhile, I want to get the highest possible grade. So that is optimization. So let's read the problem. A Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. Find the dimension of a Norman window of a maximum area when the total perimeter is 16 feet. So we have a semicircle to the top of an ordinary rectangular window. So let's draw a rectangle. So this is a rectangle. Okay, I'm going to keep the line straight. All right, I got my rectangle down, and then I want to draw a semicircle above that. Okay, so this is a semicircle, and then of course the next step is I want to determine the length and width. So let's let the base be x, and then let the height be y. So that's how I define the base and height. And then for optimization problem, we need to have two equations, one primary and one secondary. Primary and secondary. So what is primary? Primary is what the problem is asking. The problem is asking you to find the dimensions. So you need to find x, you need to find y of a Norman window of a maximum area. So they want you to maximize area. So they are trying to ask you to maximize the area when the total perimeter is 16 feet. So you have to maximize the area. So the area is equals to rectangle, right? Plus the semicircle. Okay, so can you tell me, based on the picture, how do you find the area of a rectangle, which is base times height? So that is x times y, right? And the area of a semicircle, so the area of a full circle is pi times radius square. So in this case, radius is half of x. So you have to plus pi radius, which is half of x, and then you square that. Are we done? We are not. So since this is a semicircle, we have to multiply this by 1/2. The 1/2 stands for semicircle or half circle. So overall, area, what is the area equal to? Area is equals to xy, and then plus we have a 4 times 2, so that is 1/8, right? 1/8, we have a pi, and then we have a x squared. Okay, what is my secondary? So let's use a different color for my secondary equation. So the secondary, what else do you see in this problem? That is perimeter is 16. So the perimeter means the length of all the edges, right? Okay. So perimeter, what is that equal to? We have a perimeter of a rectangle, right? So that is 2y plus x. So 2y plus x. So we have y, and we have x, and then we have to add the perimeter of a semicircle. So the perimeter of a semicircle, which is pi times the radius. So that is pi times radius. And then pi times the radius. Pi times radius. So radius is half of x. So that's it, right? What is that equal to? That is equals to 16. And you might ask me, hey, how come this is not 2y plus 2x? Because for the perimeter, we need to find this and this. Speaking of the perimeter, this doesn't count. So that's why I add 1x only, not 2x. Okay, so what is the secondary? So we have two equals in here. So the secondary, how about this? Since we have a denominator, let's multiply both sides by 2. I want to simplify the secondary. And then I will plug in the secondary to the primary. So multiply by 2, multiply by 2. So overall, the secondary is equals to, this is a 32, and then this is a 4y plus 2x, 4y plus 2x, and then plus the 2 is cancelled, and then you have a pi x. So that is my secondary. So this is my secondary. So my primary is an equation, has two independent variables at this point, x and y. I can work with that. So that means I have to either get rid of y or get rid of x. So this one, taking a look at the secondary, looks like it is not too hard to isolate y on one side. So this one, let me isolate y on one side. I can do this. I can do a 32 minus 2x and then minus pi x, and then I still have a 4y on the other side, right? As long as I divide both sides by 4. So now the secondary, we have y in terms of x. And then I will plug in the secondary into the primary. And then I am ready to take my derivative. So that is what we are going to do. So plug in the secondary to the primary. So let's go back to yellow. So the primary equation is now a equals to something is now a of x. So the primary is now a of x because x is the only independent variable. So we have x times y, which is now the secondary, divided by 4, and then we add the pi over 8 x squared, and then we simplify the math a little bit, and then we are ready to take derivatives. So let's break down the first fraction. Let's do a distribution and then break it down into multiple fractions. So a of x, that is equals to so 32 divided by 4 is 8, so that will be ax, and then minus 1/2 x squared, and then minus pi over 4, and then we have x squared, right? I break this down into 3 fractions, and then we add the pi over ax squared, and then we take the first derivative. So a prime of x, so we use a simple power rule. This is a 8, bring the 2 down, we have a x, bring the 2 down, we have a pi over 2 x, and then plus, bring the 2 down, so we have a pi over 4x. So now the first derivative is done, and then let's see what else we can do. We have a negative pi over 2 plus a pi over 4, so this one can be simplified. So just like a negative 1/2 plus 1 over 4, so we have negative 2 over 4 plus 1 over 4, that is equals to negative 1 over 4, right? So a prime of x equals to a minus x, and then do the math of that, and then minus 1 over 4, but we have a pi, so that will be pi over 4x, and then we are ready to set that equals to 0, and then we try to solve for x. So this one, I prefer to factor out the x, so which is a minus x, and then 1 this will be a 1 plus pi over 4, not minus, plus pi over 4 equals to 0, and then we are trying to solve for x. So how about this? We toss the x to the other side, so we have a equals to x times 1 plus pi over 4. When you work with an optimization problem, the numbers, they are not always nice. Sometimes you have to work with weird numbers like that, and you cannot approximate because you have to use exact value. So this one, you have a divided by 1 plus pi over 4. That's it. So the critical number is, let's put it right here. So we have x equals to a divided by 1 plus pi over 4. Usually they do not accept, if you solve a problem online, usually they do not accept complex fraction. So that means you have to get a common denominator. So that is a, so this is a 4 plus pi, right? And then you flip the 4 to the top, so x equals to 32 divided by 4 plus pi. Do not approximate, right? So this is your critical number. What is the problem asking? If you go back to the top of the beginning of this video, they are asking you to maximize the area. So this critical number is obtained from an area function, the derivative of area. So that means we have to prove that at this number there is a maximum. So there are two ways to do it. You either use a sign chart or you use second derivative test. I prefer to use a second derivative test. So since for maximum, for second derivative, so this is what we are looking for. I am looking for concave down. And then at concave down, at this x value, we have a critical number, right? So this x value, that gives me a max. I want to get this from the second derivative. So let's do the second derivative. So a double prime. Usually the second derivative is easy. So it's based on what? The second derivative is based on this. So second derivative, we have a 0 minus 1, 0 minus 1, and then minus pi over 4. So this 0 minus 1 minus pi over 4, I don't need to know what that equals to exactly. All I need to know is that is negative. So negative means the function is what? Is concave down, right? Let's plug in the number. So a double prime of 32 divided by 4 plus pi, at that number, is the function still concave down? The answer is yes, because there is no x to plug in. So when you test the second derivative, it's always negative. That means the function is always concave down. So always concave down, because there is no x to plug in. It doesn't matter what x equals to. The function is always concave down. So that is less than 0. So the function is concave down. So concave down means when x is equals to 32 divided by 4 plus pi, when x equals to this value, this is a local maximum. A local maximum when x equals to that value, because we have a concave down, and then this x is my critical value. That means at x we have a horizontal tangent, so this must be a maximum. We don't need the sign chart at all. Now, can you tell me what the dimension is? We found x. What is x? Go back to the top of the video. X is the base of the rectangle, right? I haven't find y yet. So how do you find y? So to find y, still remember this, you have equations right here. So you have to plug in x, and then you can find y. All right. Okay, let's do the plug-in. So the one last step, we do the plug-in. Let's do this in another color. So we have x equals to that, and then the y is equals to 32 minus 2 times x, and then minus pi times x divided by 4. So this, if you are not allowed to approximate, then you have to go through this math to give me an exact value. The answer is 16 divided by 4 plus pi. All right, so let's draw the normal window again. We have a rectangle, and then on top of the rectangle, we have a semicircle. So this is your y, and then this is your x. So the y is 16 plus over 4 plus pi. They put this in feet, right? And then x is equals to 32 divided by 4 plus pi feet. So that is the dimension of the Norman window that you are looking for. So if you let x be that value and y be that value, so this have find this one has a maximum area. So the area is maximized. So this area plus this area is maximized. Also, the total perimeter is 16. So which is this plus this is equals to 16 feet. All right. So that is the end of this problem. If you find my video is helpful to your learning, please subscribe, give me a like, share this video out to your friends. I appreciate your help really much. I see you all in the next problem.